Hello, Intensified Bio students. So this is your tutorial for chi-square analysis. This is Ms. Sotomayor, and I want to go over how the chi-square calculator works for those of you that are doing a sample choice 3 type of experiment where you are doing a field observation. So first, let's start with understanding what the chi-square formula is and why we need to use a chi-square analysis. So a chi-square statistic is one way to show a relationship between two categorical variables. In statistics, there are two types of variable: numerical, countable variables, and non-numerical, categorical variables. The chi-square statistic is a single number that tells you how much difference exists between your observed counts and the counts you would expect if there was no relationship at all in the population. So here we see the chi-square formula. So this x squared stands for chi squared, and that is equal to the sum of the observed value minus the expected value squared divided by the expected value. So when you first set up your proposal, I asked you to set up your choice 3 field observation in this manner. So this is an example here that I'm going to use, and then I will apply the chi-square analysis to this example. So in this particular choice 3 experiment, what a student might be doing is just observing a large field and then separating that large field into quadrants as you see right here. So maybe you've been to the outdoor lab and you've seen how there are different fields in the lab that are cleared at different rates for different purposes. But let's say you happen to be observing one of those fields and you name them. You called one field 1, and then you make a little quadrant, which is a little square area where you're going to be counting. And in this particular experiment, you're going to be counting the number of wildflowers present. Now, why? Because your hypothesis is if fields are cleared at different time intervals, then there will be a different number of wildflowers present in those fields because the wildflowers will grow at a different rate. Your null hypothesis, of course, being the clearing of fields at different time intervals will have no effect on the number of wildflowers present in those fields. So here you have field 1 quadrant that has been cleared a few days ago, field 2 quadrant that has been cleared a few weeks ago, field 3 quadrant that was cleared a few months ago, and then field 4 quadrant that has never been cleared. So of course, you are going to find, or you're going to observe, different number of wildflowers. And here I'm keeping it very simple, and I'm only gonna look at 4 different wildflowers. So let's say you looked at field quadrant 1 and you saw 19 wildflowers for that particular field observation. Now remember, this is the cumulative value over time. And you saw 4 buttercups, 7 bluegrass, 3 yellow foxtails, and 5 dandelions. And then for field 2, notice that you saw not as quite as double the amount, but close to that. You saw 31 wildflowers. Same thing for field 3. It was almost double the amount, but not quite. And then for field 4, you also saw almost double the amount, but not quite. Now, in a chi-square value, it's very important to first state a ratio of what you expect to find, right? So this is what you observe and this is what you expect to find. So in your analysis, you are going to test for your hypothesis and see if your null hypothesis is accepted or rejected. And it's very important to first set up your hypothesis because that's what you're testing. Okay. So everything that you collect, everything that you observed, needs to be set up in what we call a contingency table. So this up here, what I've set up for you, is a contingency table. Now, everything that is highlighted in yellow, please do not mess with. Do not touch. Do not touch any of the highlighted cells, because I've set up those cells with formulas already so that you don't have to do this chi-square calculation manually each time. I've set up the Excel formula for you already. So do not touch anything that's in yellow. So that means that the only area where you're going to write down information is in the area that's clear. Okay? So in this particular experiment, if I add up my sample size for quadrant 1, 2, 3, and 4, I come up with a sample size population of 180 wildflowers altogether that were observed. So then you can fill in your description here. This is field 1. Spelled here. Field 1. This is field 2. This is field 3. This is field 4, right? And every field was cleared at different rates. So I have a total of 180 wildflowers that I observed. So that's what I'm going to put in here in my observed category column. But before I do that, I have to come up with a ratio. And the ratio has to be based on your idea of what you expect should have happened. So for example, if the first field was only cleared a few days ago, then I expect to find less wildflowers than the field that was cleared a few weeks ago. So I'm going to say that in field 1, in comparison to field 2, there's going to be twice as many wildflowers in field 2 that there are in field 1. And then I'm going to say that field 3, in comparison to field 2 and 1, there's going to be 4 times as many wildflowers. And then in field 4, there's going to be 8 times as many wildflowers as everything else. And then I'm going to add up my values here. 8 plus 4 plus 2 plus 1 gives me a sum of 15. And notice how already things are changing here. And the Excel calculator is changing things for you automatically. So now I'm going to put in my observed values. So for field 1, I saw 19 wildflowers. For field 2, I saw 31 wildflowers. For field 3, I saw 50 wildflowers. For field 4, I saw 80 wildflowers. And that gives me a total of 180 wildflowers. Okay. So notice how everything was calculated here for you, and you end up with a total chi-square value of 8.8. So this is the number right here that is important. This is the number that you're going to be working with just now. Now, pay attention to this. It says here, if the chi-square value, which is this, right, is less than the critical value, then you're going to have to accept your null hypothesis. And if the chi-square value is greater than the critical value, then you're going to reject the null hypothesis. So you might be asking, well, what's the critical value? So for that, you need to move over here to this critical value table. And good thing that statisticians have already created these certainty values. So what are these chi-square p-values? So a chi-square test will give you a p-value, and we already calculated that. The p-value will tell you if your test results are significant or not. In order to perform our chi-square test and get the p-value, you need 2 pieces of information. First, you need degrees of freedom. And degrees of freedom is right here in this column. Degrees of freedom state or is calculated by the number of categories minus 1. So in your particular experiment here, you had 4 different categories. So it's 4 minus 1. So you have 3 degrees of freedom for your particular experiment. And you're also going to need the alpha level. And this is chosen by you or the researcher. And the usual alpha level in scientific investigations is 0.05 or 5%. So the alpha level is going to give you a certain amount of certainty, right? So if your alpha level is 0.05, then you can say with 95% certainty that your results are statistically significant. If you want to be if you want to scrutinize your data even further, you can choose a lower alpha level of 0.01, and then you can say with 99% certainty, right, that your results are statistically significant. So notice here that your critical value at a p certainty of 0.05 is 7.8. Now look at what your chi-square value is. Your chi-square value is 8.8. So your chi-square value is greater than 7.8. So if we go back here to what that means, right? Here your chi-square value is 8.8. It's greater than the critical value that we determined to be 7.8. So then what are you going to do? You're going to reject your null hypothesis. And what was your null hypothesis? Well, your null hypothesis is saying that the clearing of the fields at different time intervals will have no effect on the number of wildflowers present. So now you can say with a mathematical certainty of 95% that clearing those fields at different time intervals did have a significant effect, right, on the number of wildflowers that you were able to count. With 95% certainty. It doesn't quite meet the scrutiny of 0.01 or 99% certainty. But that's okay, right? You only need a p certainty or a p-value of 0.05. So that's what you're going to do with your data. Like I said, chi-square analysis, it's used a lot in experiments like genetic experiments where the predicted ratio is a set ratio. For example, if you're crossing two heterozygous dihybrid plants, you're always going to get a ratio of 9 to 3 to 3 to 1. In this particular instance, for your science fair experiment, the predicted ratio has to be determined by you, what you expect for that to happen. And that's why the chi-square calculator is going to calculate these expected values for you. So once again, make sure that when you do collect your data, right here, your data is summarized already for a total number of organisms or data points that you observed. And once you have your summary data table, you can put that in your chi-square test calculator. If you have any questions, remember that we have the mentors after school that can help you with any questions that you might have. And that is it for now.